What if I told you that the man who unlocked the deepest, most majestic secrets of the universe could not even see the stars clearly? What if I told you that the architect of modern astrophysics also wrote the world's very first science fiction novel and had to use his sheer, relentless genius to save his own mother from burning at the stake? It sounds like a dark, Gothic fiction, but the 17th century court records, the meticulously preserved scientific journals, and the deeply personal, desperate letters we are laying out today tell a very different, very real story. Welcome to Legendary Lives Unveiled. If the forgotten shadows and magnificent truths of history draw you in, I urge you to like, subscribe, and share this journey into the abyss of time. Let us unveil the past together. To comprehend the chaotic, triumphant life of Johannes Kepler, you must completely discard the dusty, peaceful textbook image of a quiet mathematician doing geometry in a serene study. The reality is a portrait of a man surviving in a world that was literally and violently tearing itself apart. This was the height of the Reformation, the brutal Counter-Reformation, and the bloody dawn of the 30 Years' War. And layered atop this immense political chaos was a massive, terrifying paradigm shift in how human beings understood their physical place in the cosmos. Imagine the sheer, crushing scale of the intellectual crisis into which Kepler was born. For over 1,000 years, the absolute, unquestionable truth, enforced by the church, the grand universities, and everyday common sense, was the Ptolemaic system. The geocentric model. The Earth was a stationary, unmoving rock at the center of the universe, and everything revolved around us in perfect, uniform circles. And honestly, it made intuitive sense. When you walk outside and look up, you do not feel like you are hurtling through the freezing void of space at tens of thousands of miles an hour. The ground feels definitively solid. The sun appears to rise. It moves steadily across the sky, and it sets. To challenge that physical sensation was not just a polite scientific disagreement. It was a lethal threat to the entire philosophical and theological order of the world. It was dangerous to even think about it. Nicholas Copernicus had already published his heliocentric theory, the concept of a sun-centered universe. Yet, by the time Kepler was born, this earth-shattering idea was largely dismissed as a mere mathematical fiction. It was treated as a neat calculating tool, a convenient hack to make predicting planetary positions a little easier, but absolutely not something that should be taken as literal physical reality. Into this absolute powder keg steps a boy seemingly destined for total obscurity. Johannes Kepler was born on December 27, 1571, in the small German town of Wilderstadt. His family's situation was, to put it mildly, a complete disaster. His grandfather had once been the Lord Mayor of the town, providing a fleeting legacy of prestige. But by the time Johannes took his first breath, the family was locked in a steep, inescapable financial and social freefall. The driving force behind this ruin was his father, Heinrich. In Kepler's own later diaries, which are brutally blunt, he described Heinrich as a vicious, inflexible, and quarrelsome man. Heinrich was a mercenary soldier, driven by violence and coin rather than any principle. The Kepler family was officially and devoutly Lutheran, yet Heinrich actively hired himself out to fight for the Catholic Spanish army, violently suppressing the Protestant uprising in the Netherlands. He was a man fighting against his own religion, rarely home. Heinrich eventually abandoned the family entirely when Kepler was just 5 years old. Young Johannes was left with his mother, Katharina, a woman who would cast a massive, fateful shadow over his entire existence. Katharina was an innkeeper's daughter, who worked as an herbalist. She gathered roots, mixed arcane potions, and attempted to heal local ailments. In the paranoid, hyper-religious context of late 16th century Germany, this was the absolute worst profession one could hold. Being an abrasive woman dealing in folk medicine placed a giant lethal target on her back. This was the peak era of the European witch hunts, where superstition was not a fringe belief, but a legally recognized reality that could drag you to court and to the stake. Her own family bore this dark stain. Katharina's aunt had already been burned alive for witchcraft, and Katharina herself possessed zero diplomacy. Kepler, never one to sugarcoat the truth, described his own mother as swarthy, gossiping, and of a notoriously bad disposition, an absent, violent father, an abrasive, socially marginalized mother, crushing poverty. And on top of this immense psychological trauma, Kepler's physical body began failing him almost from birth. Born prematurely, he was constantly sickly, but the defining physical trauma struck when he was just 3 years old: smallpox. Surviving the disease in the 1570s was a miracle, but the lingering devastation was permanent. The pox crippled his hands, leaving them deformed, and severely damaged his eyesight. He suffered from polyopia, meaning he saw multiple, fragmented images instead of a single clear one, and he was left severely myopic, incredibly nearsighted. Let us pause and unpack the agonizing irony of this reality. The man destined to become the greatest observational theorist of his era, the genius who would literally map the orbits of the planets with mind-bending precision, had crippled hands and could not clearly see the stars. At that time, the true rock stars of the scientific world were the observers, the men with razor-sharp vision who built giant physical instruments to log the exact positions of celestial bodies. Telescopes had not yet been invented. Kepler knew he could never physically do the prestige work. He couldn't be a premier observer, so he had to become the ultimate theoretical architect. He had to take the massive catalogs of numbers that others observed and deduce the hidden, underlying structure. His genius was not in seeing the glowing dots of light. It was in deciphering the invisible lines connecting them. Despite his shattered vision, the heavens mesmerized him. 2 profound childhood memories burned into his mind. In 1577, his mother dragged him up a hilltop to witness the Great Comet, a terrifying omen to most, viewed as a harbinger of plague or the death of kings, but to young Kepler, a source of pure, fearless wonder. 3 years later, his father, briefly home from a war, took him into the dark to witness a lunar eclipse. The seed was planted. Frail and crippled, he could never be a laborer or a soldier. His only escape from grinding poverty was his phenomenal brain. As a child, he entertained travelers at his grandfather's inn by performing incredibly complex mathematical calculations in his head as a mere party trick. This raw, blistering talent caught the attention of the local Protestant authorities. The Duke of Württemberg had established a specific scholarship pipeline to find poor but brilliant boys and train them to become Lutheran clergymen. Kepler won a spot. In 1589, he set off for the University of Tübingen, fully intending to spend his life as a devout pastor. But at Tübingen, he met the most important mentor of his life, Michael Mestlin, the astronomy professor living a bizarre, dangerous double life. Publicly, at the lectern, Maestlin taught the state-sanctioned, church-approved Ptolemaic system. To do otherwise meant losing his job, or worse. But privately, behind heavy closed doors, he pulled his brightest students aside and unveiled Copernicus. Maestlin immediately recognized Kepler's brilliant mathematical mind and introduced him to the heliocentric theory, Most astronomers viewed the sun-centered model merely as a saving the appearances trick, a hack for the math. But Kepler's reaction was entirely different. He instantly accepted the moving Earth as literal, physical reality. Through his intense theological lens, he looked at this sun-centered universe and literally saw the mind of God. Emerging from a chaotic, abusive childhood and a family steeped in dark superstitions, Kepler found salvation in a mathematically perfectly ordered creator. Kepler's God was a geometer. If the universe was created by a perfect, rational God, then its physical arrangement had to follow perfect, beautiful mathematical principles. He refused to accept a messy, random cosmos because that would imply an imperfect creator. This desperate search for divine mathematical order became the singular obsession driving every scientific pursuit of his life. Poised to become a highly educated Lutheran pastor, his destiny abruptly derailed. The Protestant school in Graz needed a mathematics teacher after their previous one suddenly died. The university essentially forced Kepler to go. Devastated, feeling he was abandoning his sacred calling to the church, he moved to Graz in 1594 and took up the chalk. He was, by all historical accounts, an absolutely terrible teacher. He mumbled endlessly in Latin, constantly lost his train of thought, and wandered off on obscure geometrical tangents that his teenage students couldn't begin to comprehend. Within his first year, his classrooms were utterly empty, but his duties as the district mathematician included publishing annual astrological calendars. In the 1590s, astrology and astronomy were essentially the exact same field. The astronomer tracked the dots. The astrologer interpreted their physical effects on the Earth, much like predicting the weather or the tides. In his very first calendar, Kepler predicted a severe, exceptionally cold winter and a brutal invasion by the Ottoman Turks. Both happened flawlessly. Overnight, the bumbling math teacher transformed into a revered local prophet. Yet, the true axis of his life shifted not in a calendar, but in front of one of those empty Graz classrooms in July 1595. He was drawing an equilateral triangle inscribed inside a circle, and then another circle inside that triangle. Staring at the geometry, a massive realization washed over him. He knew from Copernicus that there were exactly 6 planets: Mercury, Venus, Earth, Mars, Jupiter, and Saturn. His brain agonized over the divine why. Why exactly 6 planets? Why those specific, seemingly random distances from the sun? Modern science accepts the random accretion of dust and gas, but Kepler demanded a divine blueprint. Looking at the flat chalkboard, he realized he was thinking too small. The universe is 3-dimensional. And in 3D geometry, there exists a unique, unbreakable set of shapes known as the Platonic solids, regular, convex polyhedrons, where every single face is identical in size and shape, and the exact same number of faces meet at every vertex. Because of the strict, unforgiving rules of 3-dimensional space, there can mathematically only be exactly 5 of these perfect shapes in existence: the tetrahedron, 4 triangles; the cube, 6 squares; the octahedron, 8 triangles; the dodecahedron, 12 pentagons; and the icosahedron, 20 triangles. You literally cannot construct a 6th. 5 perfect shapes, 6 known planets. 6 planets leave exactly 5 empty spaces between their orbits. It was an explosive revelation. Kepler theorized that God had taken the invisible, crystalline spheres of the planets and nested the 5 Platonic solids tightly between them as structural spacers, a cosmic set of Russian nesting dolls made of absolute divine geometry. He ran the calculations using Copernicus's estimated distances, and the math was shockingly close. close enough that Kepler believed, with every fiber of his being, that he had literally read the mind of God. He published this ecstasy in 1596 in his first major book, Mysterium Cosmographicum, The Cosmic Mystery. The craziest part about this masterpiece? Its fundamental premise was objectively completely wrong. Planets are not nested inside invisible geometric blocks, and the later discoveries of Uranus and Neptune would shatter the five-shape theory entirely. Yet, this massive mistake effectively invented the discipline of astrophysics. Before this book, astronomy was purely descriptive kinematics, tracking dots and creating formulas to predict where a dot would be next Tuesday. No one asked why it moved. Kepler was the first human in history to demand a structural, physical, geometric cause for the arrangement of the solar system. He sent copies of his audacious book across Europe. One landed in Italy, politely acknowledged by a man named Galileo. But more importantly, a copy reached the most famous, most heavily resourced, and most deeply eccentric astronomer on the face of the Earth. And just as Kepler's life in Graz was about to violently collapse under the sword of religious persecution, this single book would drag him into the orbit of a man who would either secure his legacy or drive him entirely mad. The man who received that audacious book was Tycho Brahe. And Tycho is a fascinating character study in complete, almost absurd contrast to Kepler. Brahe was an astronomically wealthy Danish nobleman. He had previously owned an entire island, Uraniborg, funded by the King of Denmark, where he built what was essentially the world's first massive scientific research institute. But to understand Tycho, we absolutely must talk about his face, specifically his nose. As a university student, Tycho became embroiled in a furious argument with another student over a mathematical formula. Their solution? The only rational way a 16th century aristocrat could settle a math dispute, a sword duel in the pitch black of night. Naturally, Tycho lost, and a large chunk of his nose was sliced right off. For the rest of his life, he wore a prosthetic nose made of brass, though he supposedly kept silver and gold ones for special occasions. This perfectly sums up the man: flamboyant, arrogant, and incredibly combative. He threw wild, lavish banquets at his castle. He employed a little person named Jep as a jester, who sat under the dining table and supposedly possessed psychic powers. He even had a pet elk, an elk that tragically died after drinking too much beer and falling down a flight of stairs. You cannot fabricate this level of aristocratic madness. But beneath all that eccentric, flamboyant bluster, Tycho Brahe was an unparalleled observational genius. Keep in mind, the telescope had not yet been invented. Using only his naked eye, Tycho spent decades building massive, wall-sized quadrants and sextants. His instruments were so incredibly large and so precisely calibrated that he compiled the most accurate catalog of star and planetary positions in human history. His data was the absolute gold standard of the era. No one else even came close. By the late 1590s, Tycho had fallen out of favor with the new Danish king and relocated to Prague, securing the title of imperial mathematician for the Holy Roman Emperor, Rudolf II. Tycho read Kepler's Mysterium Cosmographicum. He thought the divine geometry was unproven, but he recognized Kepler's raw, blistering mathematical processing power. Tycho desperately needed a number cruncher to prove his own convoluted model of the solar system, so he invited Kepler to Prague. The timing was an act of grim providence. At that exact moment, Kepler's life in Graz was completely imploding. The Counter-Reformation had arrived. The Catholic Archduke Ferdinand decreed that all Protestants in the region had to either convert to Catholicism or go into absolute exile. Kepler, deeply devout, flat out refused to convert. The consequences were brutal. He was stripped of his teaching post and banished. Tragically, when his infant daughter died during this chaotic period, the Catholic authorities fined him heavily simply for refusing Catholic burial rites. Destitute, grieving, and practically homeless, Kepler packed up his family in 1600 and headed to Prague to work for the man with the silver nose. What followed was the ultimate toxic workplace dynamic. A nightmare scenario. You have Tycho, the wealthy, arrogant aristocrat hoarding his data like a dragon. And you have Kepler, the sickly, puritanical, hyper-focused mathematician who desperately needed that data to fix the flaws in his cosmic nesting doll theory. They clashed constantly. Tycho treated Kepler like a subordinate human calculator, tossing him only mere scraps of planetary data, never the full ledgers. Kepler would become furious, demand more access, and at one point, threw a massive tantrum that resulted in him being temporarily kicked out of Tycho's castle. They eventually negotiated a tense truce. But to keep the younger man in line, Tycho intentionally assigned Kepler the absolute hardest, most frustrating mathematical task in the entire observatory: mapping the orbit of Mars. Why was Mars the nightmare assignment? Of all the known planets, Mars exhibited the most erratic, non-circular behavior in the sky. Its retrograde motion, the way it appeared to sometimes slow down, stop, and actually move backward in the night sky, was severe. It blatantly defied the ancient, sacred rule of perfect circular orbits. Tycho gave it to Kepler essentially as busy work from hell. Kepler, completely underestimating the cosmic trap he was stepping into, made a famous bet. He looked at Tycho and promised he would solve the orbit of Mars in 8 days. 8 days. But before he could even make a dent, the ultimate plot twist occurred. In October 1601, Tycho Brahe attended a lavish banquet in Prague. He drank heavily, as usual, but out of strict court etiquette, he refused to leave the table to relieve himself. He held it in for hours. When he finally returned home, he was in excruciating pain, completely unable to urinate. He fell into a feverish delirium and died 11 days later. On his deathbed, terrified that his life's work would amount to nothing, he kept repeating, "Let me not seem to have lived in vain." Which brings us to the true crime elephant in the room. Tycho dies suddenly, and just 2 days later, Johannes Kepler is officially appointed to his position as imperial mathematician. Crucially, Kepler physically secures Tycho's massive vault of data, literally fighting off Tycho's own heirs to keep it. He essentially stole a lifetime of observations. From a modern perspective, the timing is incredibly suspicious. For years, rumors swirled that Kepler poisoned Tycho with mercury. This theory exploded in the late 20th century, fueled by traces of mercury found during an early exhumation. But we must clear Kepler's name of murder. In 2010, modern forensic science finally settled the debate. An international team exhumed Tycho's bones and his famous mustache hairs, using highly advanced spectrometry. The results conclusively proved there were absolutely no lethal levels of mercury, only background exposure from Tycho's own alchemy experiments. Medical historians now agree Tycho died of a natural, albeit agonizing cause: a burst bladder, an enlarged prostate, or a severe urinary tract infection leading to uremia. Kepler inherited the data cleanly. He sat down with the Mars ledgers. He thought it would take 8 days. It took him 5 years. 5 years of relentless punishing math, producing over 900 pages of longhand arithmetic. Visualize this: before calculus, before mechanical calculators. Sitting at a candlelit desk, multiplying and dividing massive fractions by hand, over and over, with permanently crippled eyesight. His methodology was an exhausting process of trial and error. Starting with the orthodox assumption that Mars must move in a perfect circle, He built a mathematical model called the vicarious hypothesis. He mathematically shifted the center of the orbit slightly away from the Sun, adjusted speeds relative to imaginary points, and tweaked the geometry endlessly. And he succeeded. He built a circular model that perfectly predicted Mars's horizontal position in the sky, what astronomers call the longitude. The vicarious hypothesis was a massive triumph, but Kepler possessed an absolute, uncompromising scientific integrity. He tested his beautiful working model against two extremely difficult observations Tycho had made of Mars at opposition. At opposition, the Earth is positioned in a straight line exactly between the Sun and Mars, like a perfectly aligned string. Measuring that exact angle requires pinpoint precision. Kepler checked his math against Tycho's opposition data, and the model failed. It didn't fail by a massive margin. It failed by exactly 8 arc minutes. To understand the insanity of what Kepler does next, you must understand the microscopic scale of an arc minute. A circle has 360 degrees. Each degree is split into 60 minutes. 1 arc minute is 1/60th of a single degree. If you hold a coin completely flat, edge-on, at the length of a football field, the thickness of that coin is about an arc minute. 8 arc minutes is roughly the width of a pinhead held at arm's length against the vast night sky. To literally any astronomer before Kepler, including Ptolemy and Copernicus, an error of 8 arc minutes was perfection. Ancient instruments were so blurry that such a tiny discrepancy was easily chalked up to atmospheric distortion or human error. Anyone else would have published the book and taken the glory. A model that is 99.99% correct? Just shrug and say Tycho's eyes must have been tired that night. What did Kepler do? He threw every single page into the trash. He knew Tycho Brahe. He knew Tycho's giant instruments were reliably accurate to within 1 or 2 arc minutes. Therefore, Kepler reasoned, the 8 arc minute error was not a mistake in the data. It was a fundamental flaw in the theory of the universe itself. He famously wrote, "Because these 8 minutes could not be ignored, they alone have led to a total reformation of astronomy." He concluded the 2,000-year-old dogma was dead. Planets do not move in perfect circles, but if it's not a circle, what is it? Entering a dark mathematical room, he assumed the orbit must be an oval. Specifically, he became obsessed with an egg shape, fatter on one end. He believed magnetic forces from the Sun varied, bulging the orbit out. He spent over a year calculating 40 different variations of egg-shaped orbits. None aligned with Tycho's data. He described the agonizing process as driving a herd of cattle through a maze. Finally, exhausted, he tried a shape studied by the ancient Greeks, but completely ignored by astronomy: the ellipse. An ellipse has 2 internal points called foci. If you tack a string to those 2 foci, pull it tight with a pencil, and draw, you get a flattened circle. When Kepler dropped the ellipse over Tycho's Mars data, with the Sun sitting not in the center, but off to the side at one of those 2 foci, it fit perfectly. Not sort of perfectly. 8 arc minutes perfectly. This shattering breakthrough led to his 1609 masterpiece, Astronomia Nova, the New Astronomy, laying out his first law of planetary motion. Planets move in ellipses with the Sun at one focus, but the puzzle wasn't finished. Because the planet moves in a stretched-out shape, its distance from the Sun is constantly changing. This birthed his second law, which destroyed another ancient rule: uniform speed. For millennia, philosophers dictated that divine heavens must move at a constant, unchanging speed. Kepler proved they don't. Imagine a pie chart overlaid on the elliptical orbit. When the planet is far from the Sun, it moves very slowly tracing a short, wide pie slice over a month. When it whips close to the sun, it moves incredibly fast, tracing a long, skinny pie slice in that same month. Kepler proved that the total geometric area inside the short, fat slice is exactly identical to the area inside the long, skinny slice. His second law, a line segment joining a planet, and the sun sweeps out equal areas during equal intervals of time. Staggeringly beautiful math. And again, he asked why. If the planet speeds up near the sun must be the physical engine driving it. Kepler coined the term anima motrix, a motive force. He realized the sun wasn't just a lamp. It rotated and cast out invisible magnetic spokes that dragged the planets along. He was astonishingly close to gravity. Isaac Newton would finalize it decades later, but Kepler was the absolute first human to introduce physics into astronomy. And we must acknowledge the terrifying luck of it all. If Tycho's data had been slightly less accurate, say 10 arc minutes, Kepler would have accepted the circular model. Conversely, if he had modern telescope data, he would have seen tiny gravitational wobbles caused by Jupiter, and the perfect ellipse wouldn't have worked either. Tycho's naked eye data sat in the exact, perfect sweet spot of precision that allowed Kepler's mind to pierce the noise. Yet, with Astronomia Nova published, Kepler faced a massive public relations problem. Nobody was going to read a giant math textbook. He proved the Earth is rocketing through space. But how do you explain that to a public who demands to know why we don't feel a massive headwind? Or why birds aren't ripped from the sky? Realizing that dense equations wouldn't shift visceral human perception, Kepler turned to a medium completely unprecedented for an imperial mathematician. He wrote a fantasy novel. He circulated a Latin manuscript called Somnium, the Dream. Championed centuries later by heavyweight thinkers like Carl Sagan and Isaac Asimov as the very first true work of science fiction in human history, Kepler used a sci-fi story about witches, demons, and lunar travel to sneak astrophysics past his harshest critics. It was a brilliant epistemological trick. But the supreme tragedy of Kepler's life is that this beautiful, creative endeavor, designed to enlighten humanity, would become the very weapon used to almost destroy his family, dragging his mother into the most harrowing witch trial of the 17th century. The narrative Kepler constructed to sneak astrophysics past his critics was a manuscript in Latin called Somnium, which translates to the Dream. Heavyweight thinkers like Carl Sagan and Isaac Asimov would later champion this text as the very first true work of science fiction in human history. The plot itself is wildly creative, yet intensely deliberate. The narrator of the story falls asleep while reading a book about magic and dreams of a young Icelandic boy named Duracotus. Duracotus has a mother named Fiohilda, a wise woman, essentially a witch, who sells herbs and magical charms to sailors. Fiohilda knows a secret, arcane ritual to summon a demon from a distant world called Lavania, which is Kepler's name for the moon. This demon provides them with a method of travel across the black void of space to visit the lunar surface. It sounds like pure medieval fantasy, but it was, in reality, a masterful epistemological trick. Epistemology is the study of how we know what we know, the eternal battle between human perception and physical reality. Kepler's goal was a massive thought experiment. In the story, when Duracotus stands on the moon, Lavania, and looks down at his feet, the moon feels perfectly solid and stationary. But when he looks up at the Earth appears to be spinning wildly and moving rapidly across the sky. He is telling the reader, if you lived on the moon, you would swear the moon was still and the Earth was moving. Therefore, your feeling that the Earth is still right now is just an illusion of your perspective. It completely disarmed the central visceral argument against Copernicus. But the genius of Somnium lies in the intense, rigorous scientific detail Kepler wove into the narrative. He accurately predicted the physical effects of space travel. The demon warns that the initial acceleration of the launch will be incredibly violent, pushing the travelers back against the force of motion, an early understanding of G-forces, written in the 1600s. Kepler also describes a point during the journey between the Earth and the Moon, where the pull of both bodies cancels each other out, and the travelers experience complete weightlessness. He understood the concept of zero gravity decades before Isaac Newton formulated the law of universal gravitation, and he went further, engaging in early speculative biology. He envisioned two types of aliens: the subvolvans, who live on the side of the moon facing Earth, and the provolvans, who live on the dark side. He reasoned that because half the moon is exposed to brutal boiling sunlight for 2 weeks, while the other half is plunged into deep, freezing darkness, lunar creatures would have to evolve incredibly tough, thick, scaly hides to survive the solar radiation. He described massive, rapid plant growth that springs up and dies in a single lunar day, and theorized that the inhabitants would have to build massive underground cave systems to escape the temperature extremes. He was literally predicting evolutionary adaptation to extraterrestrial environments. The story itself was only a few dozen pages long, but Kepler spent the rest of his life obsessively adding footnotes to explain the math and physics behind the narrative. By the time it was finally printed after his death, he had added 223 footnotes, making the footnotes actually longer than the story itself. It was a brilliant piece of scientific communication. But the supreme tragedy of Kepler's life is that this creative endeavor, this fictional story designed to enlighten humanity, became the very weapon used to almost destroy his family. Manuscript copies of Somnium had been circulating quietly among academics for several years. Kepler later wrote with absolute certainty that this manuscript leaked out to hostile people in his home region. They read the story, recognized the obvious parallels, and used the witch mother character, Fjolghilde, as proof that Johannes Kepler himself was openly admitting his mother consorted with the devil. After all, who was Kepler's real mother? Katharina, a cantankerous herbalist who collected roots and was suspected of folk magic. In 1615, real life morphed into a literal horror movie. Katharina Kepler, now an elderly woman in her late 60s, living in the town of Leonberg, was formally accused of witchcraft. And it started over something incredibly petty. A local woman named Ursula Reinbold, the wife of a glazier, had a bitter argument with Katharina. Shortly after, Ursula fell ill and claimed that Katharina had given her a bitter, magical potion that made her sick. In the paranoid, hyper-religious atmosphere of 17th century Germany, that single accusation was like tossing a match into a fireworks factory. The entire town piled on. Neighbors testified that Katharina transformed herself into a cat. A local tailor claimed she magically appeared in his locked room. Another woman said Katharina looked at her children and caused them to sicken and die. A schoolmaster claimed that Katharina had lightly brushed against his leg in the street, and he was instantly paralyzed by a magical curse. We hear these things today, and we laugh at the absurdity. But this was not a joke. This was a capital crime, and people died over it. The prosecuting bailiff for the region was a man named Lutherus Einhorn, an absolute fanatic who genuinely believed his divine mission was to cleanse the land of Satan's servants. Prior to Katharina's trial, Einhorn had already accused over a dozen women of witchcraft and had successfully sent 8 of them to be burned at the stake. As the legal net tightened around Katharina, her own family completely abandoned her out of sheer terror. Her other son, Christoph, a local tinsmith, publicly disowned her because he was afraid the association would ruin his business. Her daughter, Margarita, couldn't provide any legal or financial help. The entire defense of Katharina's life fell solely on the shoulders of Johannes Kepler, the imperial mathematician. The man who just rewrote the laws of the cosmos had to drop all of his scientific work, pack up his entire family, and move back to a hostile town to fight a legal battle against a fanatic for 6 grueling, terrifying years. Things reached a crisis point in August 1620. Katharina was officially arrested in the middle of the night. For 14 agonizing months, this elderly woman, now over 70 years old, was chained to the stone floor of a prison cell. 2 guards were stationed with her day and night to ensure she didn't use magic to escape. And in one of the cruelest twists of the legal system, Katharina herself was forced to pay the wages of the guards who were tormenting her. They employed a psychological torture tactic called territio, the formal showing of the instruments of torture. They dragged this chained elderly woman down into the torture chamber, where the executioner meticulously explained exactly what the rack would do to her joints and exactly how the glowing hot pincers would tear her flesh unless she confessed to being a witch. But Katharina Kepler refused to break. She looked her interrogators in the eye and famously told them that they could pull every single vein out of her body, one by one, and she would still have nothing to confess. She told them that if they killed her, God would eventually reveal her innocence. Her iron will stalled the execution, giving Kepler time to launch his final defense. And here, Kepler used his true genius. He didn't argue theology, or demons, or angels. He brought the exact same rigorous logical scientific methodology he used to map the orbit of Mars and applied it directly to a witch trial. He wrote a massive 126-page legal defense brief, a masterpiece of early forensic logic. He forensically dismantled the prosecution's case witness by witness. For the schoolmaster paralyzed by a magical touch, Kepler consulted medical texts and physicians, proving the man had a long documented history of lumbago and vascular issues. The paralysis was a natural result of a stroke, not a curse. As for Ursula Reinbold, the woman who started it all, Kepler investigated her background and found she had a history of unauthorized abortions, which involved taking harsh, toxic herbs. He argued that Ursula's illness was a direct medical consequence of her own dangerous botanical concoctions, and she was simply using Katharina as a scapegoat to hide her crimes. Piece by piece, Kepler used medical science, timelines, and basic physics to prove that every single magical event had a perfectly mundane, natural explanation. It was the ultimate showdown of the Renaissance era, the dawn of rational science, literally battling the darkest depths of medieval superstition in a courtroom. And, incredibly, it worked. The legal authorities in the Duke's High Court read the brief, found the local evidence completely insufficient, and in late 1621 ordered Katharina's acquittal and release. She survived the trial, but the cost was unfathomable. The trial completely bankrupted Kepler, costing over 900 guilders in legal fees and prison bribes, more than 2 entire years of his imperial salary. Katharina was physically and emotionally broken by the ordeal. Forbidden to return to her home village due to the lingering dangerous mob mentality, she died just 6 months after her release. Kepler saved her life, but he lost his mother anyway. One can only wonder about the devastating psychological toll. Did he lie awake at night, knowing his sci-fi story was the match that lit the fire? And as if that were not enough, Kepler emerged from this 6-year legal nightmare only to find that the entire continent of Europe was literally on fire. While he was chained to a courtroom, the political tensions snapped in 1618. Protestant nobles staged a revolt in Prague, dragging 3 Catholic imperial officials to a window and throwing them out. A 70-foot drop, known as the famous Defenestration of Prague. Amazingly, they survived by landing in a massive pile of manure in the moat. The Catholics claimed angels caught them. The Protestants pointed out it was literal horse manure. But that event detonated the 30 Years' War. It was not just a series of battles, it was a total societal collapse. Roving armies of mercenaries swept across Central Europe, pillaging, burning, and bringing massive waves of disease. The population of some German states dropped by over 50%. Millions died from starvation and plague. Kepler was caught right in the crossfire. A prominent Protestant living in Catholic-controlled territories, he was constantly forced to flee. His home in Linz was requisitioned by the military and turned into a garrison. The soldiers actually confiscated his library and ripped the pages out of his scientific books to use as wadding for their muskets. His personal life shattered alongside the continent. Disease ran rampant. He lost his first wife, Barbara, to the spotted fever, and multiple children died in their infancy. He was desperately poor because the imperial treasury refused to pay his salary during wartime. Furthermore, his own people turned against him. Because of his independent views on the theology of communion and his refusal to sign a strict dogmatic loyalty oath, his own Lutheran church officially excommunicated him. The Catholics wanted to banish him. The Protestants excommunicated him. His family was dying. His mother was almost burned at the stake. Armies were tearing up his books for musket fire. His life was a portrait of absolute, unmitigated chaos. And yet, what did he do? In 1619, right as the war was exploding, he published his magnum opus, a book called Harmonicus Mundi, or The Harmony of the World. Surrounded by slaughter, disease, and hatred, Kepler looked at the sky and found a sanctuary of perfect mathematical peace. The core premise of Harmonicus Mundi is that the universe is literally a musical instrument played by God. He took his discovery that planets change speed, moving faster near the sun and slower further away, and he assigned musical notes to those speeds. He calculated the angular velocity of each planet at its closest and furthest points, finding that the ratio between those speeds formed perfect musical intervals, like perfect fifths or major thirds. He believed the planets were constantly humming an invisible, mathematical music of the spheres. For Earth, whose nearly circular orbit changes speed very little, the song is just 2 notes oscillating back and forth. Mi, fa, mi. Kepler joked that Earth sings mi, fa, mi, because in this world, only misery and famine exist. But buried deep inside this mystical book about singing planets is one of the most important equations ever written, Kepler's third law of planetary motion. The first 2 laws described how a single planet moves. The third law united the entire solar system into a single mathematical system. The law states the square of a planet's orbital period is directly proportional to the cube of its semi-major axis. Let us break that dense math down. The orbital period is the time it takes a planet to make 1 lap around the sun. For Earth, that is 1 year. The semi-major axis is essentially the planet's average distance from the sun, half the length of the longest part of its elliptical orbit. If you take a hypothetical planet X that is exactly 4 times further away from the sun than Earth, its distance is 4. The cube of 4, 4 times 4 times 4, is 64. Kepler's law says the square of the time it takes to orbit must also relate to 64. What number multiplied by itself equals 64? 8. Therefore, A planet that is 4 times further from the Sun will take exactly 8 Earth years to complete one orbit. Kepler proved that this incredibly precise, locked-in mathematical ratio applies to every single planet in the sky. If you know how long it takes a planet to orbit, you can instantly calculate exactly how far away it is. It is a universal law. This exact same mathematical formula dictates how the Moon orbits the Earth, how the moons of Jupiter orbit Jupiter, and how modern artificial satellites orbit the Earth today. When engineers launch a GPS satellite, they are using Kepler's third law to figure out how high to place it so it orbits at the correct speed. And he figured this out by hand, by candlelight, in a war zone. He finalized his life's work by fulfilling his promise to Tycho Brahe. In 1627, he finally published the Rudolphine tables. Based on elliptical orbits and changing speeds, this massive catalog allowed anyone to predict the exact positions of the planets far into the future, and was orders of magnitude more accurate than any astronomical tables in human history. But Kepler never got to enjoy the triumph of his work. The tragedy of his earthly life hounded him to his last breath. Deeply in debt, his family struggling to survive, the imperial court owed him years of back pay. In 1630, at the age of 58, he rode on horseback in freezing weather to the city of Regensburg to beg the treasury for what he was owed. Exhausted, he contracted a severe fever upon arriving and died within days. And the final indignity occurred shortly after he was buried in a local Protestant cemetery. The 30 Years' War swept through Regensburg. A rampaging army completely destroyed the graveyard, smashing headstones and desecrating graves. Johannes Kepler's physical resting place was completely erased from the face of the earth. He mapped the perfect, eternal order of the heavens. But his own earthly grave couldn't survive the chaos of his time. His vindication, however, came almost immediately. Just 1 year after he died, in 1631, astronomers across Europe used Kepler's Rudolphine tables to predict a highly rare event: the transit of Mercury across the face of the Sun. Previous tables were so inaccurate that no one had ever successfully observed it. But Kepler's tables predicted it down to the exact day. Right on schedule, the tiny black dot of Mercury slid across the Sun, proving beyond a shadow of a doubt that elliptical orbits and changing speeds were physical reality. His math became the bedrock foundation that allowed Isaac Newton to discover the law of universal gravitation half a century later. As we wrap up this staggering journey, I want you to sit with a final provocative thought. Think about the brutal friction in Kepler's life. What if that friction was the exact catalyst needed to unlock his genius? Imagine if his eyesight had been perfect. He likely would have just been another sharp-eyed observer, logging endless lists of stars like Tycho Brahe, never forced to look for the deeper architectural patterns. Imagine if the religious wars hadn't driven him out of Graz. He never would have gone to Prague, never endured Tycho's toxic castle, and never gotten the Mars data. Did the unpredictable, violent chaos of his everyday life force his mind to build an orderly, perfect refuge in the stars? If his life had been comfortable, would he have possessed the desperate, obsessive drive needed to calculate 900 pages of fractions by hand? Did he need the crucible of adversity to forge the laws of the universe? It is something profound to think about the next time you look up at the night sky. If this journey through the cosmos and the courtroom changed how you see history, please hit subscribe, leave a like, and share this with a friend who loves a true story. Drop a comment below. What surprised you most about Kepler's life? Was it the fact that he wrote early sci-fi, or the harrowing forensic defense of his mother in a witch trial? Let us know in the comments. Thank you so much for joining us on Legendary Lives Unveiled. Keep looking up, and we'll see you next time.